Hello students and welcome to my channel. In last video we have discussed what are the pure substances and elements, metals, non-metals and all that. Now we are going to discuss what are mixtures, homogeneous, heterogeneous and whatever, right? So homogeneous mixture are what?
Hey, what about vegetable salad? I like it. It's so colorful. Is it a mixture?
Yes, you're right. Observe carefully. The salad contains a variety of vegetables like carrot, cucumber, beetroot, tomato, cabbage, and onion. You can segregate each of the vegetables from one another, isn't it?
So these vegetables which are placed in a plate, right? So it is a kind of mixture. Why the term mixture is used? Whenever you use the term mixture, that means we can separate out each and every component of the mixture. Is it? When we separate each and every component of the mixture, that is why it is called mixture. It is not the solution, it is not the homogeneous one. But now,
Yes. So, vegetable salad is a mixture.
A mixture is matter that consists of two or more substances which may be elements, compounds, or both mixed together physically in any proportion,
note it
but
down.
not chemically combined. For example, air is a mixture.
First point. Mixtures are those combinations of substances or any compounds that are not chemically mixed, right? Not chemically bonded. They are just mixed only.
Of gases like oxygen, nitrogen, carbon dioxide, etc. These gases are not chemically combined with one another and can be separated by suitable means. Based on the distribution of the particles in the mixture, there are two types of mixtures, heterogeneous and homogeneous mixture. A mixture that is not uniform throughout is called a heterogeneous mixture. For example, a mixture of sugar and salt is a heterogeneous mixture because the sugar and salt particles can be segregated based on their color and size. Examples of heterogeneous mixtures are iron fillings and sulfur powder, concrete, which is a mixture of cement, water, sand, etc. The second type of mixture is a homogeneous mixture. Observe the solution.
So you can see heterogeneous and homogeneous mixture. In heterogeneous, the parts which are being mixed, they can be seen separately, but in homogeneous mixture, they cannot be separate. They cannot be seen separately, right? That you can see this salt solution, right? It is a mixture actually. Here you cannot see the salt, but you can see the entire solution.
This is a solution of salt in water. How does this salt solution appear to you? It looks uniform throughout. So, such a type of mixture is known as a homogeneous mixture. Brass, a mixture of copper and zinc. Salt solution, a mixture of salt in water, and a solution of alcohol in water are examples of homogeneous mixtures. Now, let's observe some of the properties of a mixture. There is no definite proportion in which the constituents of a mixture combine. For example, the mixture of salt and sand can be in any ratio. The parts of a mixture can be separated by physical means.
Yes.
For example, a mixture of iron filings and sulfur can be separated by using a magnet. When a magnet is placed in the above mixture of iron filings and sulfur, the iron particles are attracted by the magnet, while sulfur particles remain unattracted. When a mixture is created, no new substance is formed. Each part of a mixture retains its own properties.
So point is, when a mixture is created, no new substance is formed. Correct? Because to form a new substance, there has to be chemical bonding, right? So in mixture, no chemical bonding, right? Chemical bond नहीं होगा यहाँ पर. So to get a new substance, there has to be chemical bonding, correct? Old bond breaking and new bond formation. But in mixture, there is no chemical bonding. That is why there is no new substance can be formed in this.
Please. For example, we could mix various proportions of hydrogen and oxygen gas. As long as you do not ignite the mixture, the combination will form a mixture that can be separated. Energy is neither given out nor absorbed in the preparation of a mixture. For example,
एक्सोथर्मिक या एंडोथर्मिक रिएक्शन होनी चाहिए, राइट? टू make any mixture, there is no endothermic or exothermic process. And why is that so? See, when we just add, you have seen that when we just add acid, right, in water, acid in water, there is a kind of exothermic reaction. Exothermic reaction. Why exothermic? When you just pour acid into a solution of water or just a solution of water, right, it will liberate heat. In any kind of reaction where heat is liberated, that means there is exothermic reaction, and in which there is, you just try to make a reaction, you just give energy, means in the form of heat, give heat, that is endothermic reaction. So to proceed any reaction, you just have to put heat, that is endothermic. When the heat is liberated out of the reaction, that is called exothermic reaction. So in mixture, there is no heat transform, right? There is no heat transfer, neither inward nor outward. So that is why in mixture, there is no heat gain or heat loss, right? No heat absorbed.
no heat or light energy is liberated or absorbed when iron filings and sulfur are mixed together. A mixture does not have a sharp melting or boiling point.
Note all the points.
For example, sugar solution does not boil at a fixed temperature.
Hi, my name is Buddy.
Now, so one point is clear, has to be clear now. When we observe pure water, right? Pure water, suppose I am having this pure water in a beaker, right? Pure water means 100% water, 100% H2O. So the boiling point of 100% H2O is 100 degrees centigrade, right? When there is nothing other than water, then their boiling point will be, that means water will boil at 100 degrees centigrade. But when we say that we are boiling sugar solution, when we say sugar solution, but then there you would see, observe, there is a variation in boiling point. It may be 105 degrees centigrade, it may be 110 degrees centigrade, because now sugar solution depends on the concentration of the sugar solution, right? When the purity is seen, there is a fixed boiling or melting point. When any solution is mixed by, or it is being chemically combined by other substances, that there will be variation in boiling point and melting point. So pure substances have fixed boiling point and melting points.
I'm training to be a magician. I practice all day, but I do not seem to be getting things right. Let me try taking a rabbit out of my cap. Abracadabra. Abracadabra. Sorry. Okay. Let me try doing something simpler. Here's a spoonful of sugar and a glass of water. I'm going to make the sugar disappear. Hocus pocus. See? Let me try making the spoonful of chalk disappear in this beaker of water. Hocus pocus. Oops! The chalk is still there. What did I do wrong?
Because that is not chemically bonded.
This lesson is all about types of mixtures. By the end of this lesson, you will be able to identify the types of solutions, List the properties of a solution. Define concentration. Differentiate between saturated and unsaturated solutions. List the properties of a suspension. List the properties of a colloid.
Colloid.
And differentiate between solutions, suspensions, and colloids.
So these are the objectives we have to study in this chapter basically. Solution, properties, concentration means hyper concentrated hai, diluted hai, right? Saturated is what? Unsaturated is what? Suspension, colloids, and differentiation between these 3 points: solution, suspension, and colloids, right?